This is a good question for applying the terms that we just learned about, average and instantaneous quantities, which are speed, velocity, and acceleration. So in this case, we're given the position of the particle as a function of time, which is given by t squared minus 4t plus 3. So this is in meters, and then t is in seconds, right? So the first question is asking us to find the displacement during the first 2 seconds. That means we're looking for s of 2 minus s of 0, right? So how long it has traveled between 0 and 2 seconds. So let's find each of these independently. So s of 2 becomes 2 squared minus 4 times 2 plus 3. So this is 4 minus 8 plus 3, right? Here we'll get minus 4 plus 3. This is negative 1 here. And if we do for s of 0, so it's 0 squared times 0 plus 3, so it's just 3. So our displacement, which is s of 2 minus s of 0, becomes negative 1 minus 3, so this is negative 4 meters, right? And the next one is b. B is asking us to find the average velocity of the particle during the first 4 seconds. So remember the definition of average velocity. So which is given by VAVG is x2 minus x1 over t2 minus t1, right? This is a vector quantity. So in this case, t1 is 0 seconds, t2 is 4 seconds, and then x2 is found by, putting the time components into the equation, which is 4 squared minus 4 times 4 plus 3, right? This is 16 minus 16 plus 3, this becomes 3. And x of 1, which is at time 0, this is 0 squared minus 4 times 0 plus 3, this is also 3, right? So now if we substitute here 3 minus 3 over 4 minus 0, this is 0 meter per second. So that means during the first 4 seconds, the average velocity is 0 meters per second. C is asking us to find the instantaneous velocity of the particle when t equals 4. So again, when finding instantaneous velocity, which is given by just v here, you take the differential of the position, dx dt, in this case it will be, ds dt with respect to time. So d dt, which is t squared minus 4t plus 3, right? So this gives us expression for velocity, it becomes 2t minus 4. Now we're asked to find the velocity at t equals 4. So we just do 2 times 4 minus 4. So this becomes 8 minus 4. That is 4 meters per second. So that's our instantaneous velocity at time equals 4 seconds. The next one is asking us to find the acceleration of the particle when t equals 4. So again, this is very similar. So this is also asking for instantaneous acceleration, which is a equals dv dt. So we found expression for velocity up there, which is 2t minus 4. So it's just 2 meters per second squared. So it's a constant acceleration. It doesn't depend on time. That's for D. And E is asking us to describe the motion of the particle and when the particle changes direction, right? So for this one, I think we want to look at what this equation is, right? So S of t is given by t squared minus 4t plus 3. So this is quadratic function, right? So we can factorize this. If you factorize it, S of t will give you, t minus 1 and t minus 3. So that means the x-intercepts are at 1, 2 and 3, and then the y-intercept is 3 obviously from the equation. And then we can also find the mean value at, t equals 2, right? So which is around -1 here. So the equation for this is something like this, right? So it's moving at a negative speed up until 2 seconds here. This is time and this is position, but after 2 seconds, it will start to moving a positive velocity. So this is it. Thank you.